All right, quick video on the discriminant. We're talking about chapter 2.5, the discriminant. This comes right out of the quadratic formula. We can see the quadratic formula is negative bx is the x value, is negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant part is just what's underneath the radical, because that's really what drives it. That's what determines how many zeros we're going to have. And so we're focusing in on this because if it's positive in here, then we'll get some b plus or minus a value over 2a. So there's going to be two values. If it's 0, well then all that goes away and it's just negative b over 2a. So we'll get one value. One x value. If the discriminant is negative, well, if it's negative, then we're in imaginary land. We're in ax plus bi graph, so now we're doing something different. We're definitely not on the Cartesian plane anymore. So let's look at those basic rules again. Like I said, if that bx minus 4ac of the discriminant is greater than 0, we will have two distinct solutions. Which makes sense because if it's a positive number, I get some value of b plus another value, and then I get b, negative b over 2a minus a value. So again, negative b over 2a is where we look for the axis of symmetry. It is the x component of the vertex. So what we're doing is, with the rest of it, we're looking what do we add to that x value. Are we adding it to the left and to the right? Is that parabola sitting below the x-axis? If so, you'll get two values. All right. If b squared minus 4ac is equal to 0, that means we have one real solution, and that typically is where the graph will bounce off of that x-axis. So that's what we'll be looking for there. If b squared minus 4ac is less than 0, then there's no real solutions. That graph must be sitting above the x-axis. Okay. Here's our general equation. Again, standard form of your quadratic. Y equals ax squared plus bx plus c. And so let's take a look at a few examples here that we have to find out what do we have in terms of the number of x value solutions that we might have. Given x squared plus 3x minus 1. Now I've labeled the a, b, and c here. And so I've just plugged in these numbers. 3 squared, that's your b value, minus the quantity. I like to put a quantity here because sometimes these negatives get shifted around and they're tough to keep track of. But 4 times 1 times negative 1 is still is negative 4, but negative 4 times 1 is a positive 4. We get 13, which is greater than 0, so we should, when we graph that, see two distinct solutions. Okay, another example. Here's our discriminant b squared minus 4ac. We have the quadratic 4x squared minus 12x plus 9. Our a is 4, our b is negative 12, our c is 9. So plugging that in, we get negative 12 squared minus the quantity 4 times a, which is 4, times 9, which is your c value, and that's 144. Subtracting 144, we actually get 0. So in this case, there's one real solution. So when we graph that, if you were to punch that in your calculator, you would see that that probably skips off the x-axis, and so forth. All right. So then, finally, we have the last example is 2x squared minus 5x plus 6. Okay, in this situation, our a is 2, our b is negative 5, our c is 6. So our b value, negative 5, gets squared minus the quantity 4 times 2 times 6, your a and c values. In this case, it's 25 minus 48, which is a negative 23. So that negative 23 would be under the radical, which means then we are in a negative, which means we have no real solution. Okay, so that is the discriminant. Hope you enjoyed that. Have a great night. Talk to you soon.